We first do the importation of NumPy, Pandas, Matplotlib, PyPlot, Seaborn, Pylab, scalar matrix, and on the data understanding, we load the churn data, and this is the columns. All in all, there are 58 columns, and on the data cleaning, first of all, we sum the null values, and as you see, on revenue, there are 141, phones, models, and EQP days there are 1, and we solve the missing values by putting mean value on it. So as you see, we sum it again. There's null value. We can see there are some float data types, and we converted it into int, and here they're all int. We store the df data into new data, and this is it. This is the data visualization. We transform the numerical data into categorical, and this is the churn versus revenue. This is the churn versus drop and unanswered voice calls. This is the churn versus customer care, and churn versus peak and off-peak voice calls, churn versus days of current equipment, churn versus unique active subscriber, and churn versus occupations, churn versus subscribers. And as you see here, the no is higher. It reached 1.6 million rather than yes, it only has 1.2. Next is the churn versus drop and unanswered voice calls. The drop voice calls has reached 151,000, while the yes is only 124, and the unanswered voice calls, it reached 920,000 and 562, while the yes is only 530 and 756,000. Next one is churn versus customer care. The no has reached 69,423, while the yes, it's only 31,426. Next one is the peak voice call. It has reached 2.5 million, while the yes is only 1.2 million. And on the peak voice, it has reached 2.6 million, while the yes is 1.6 million only. The churn versus days of current equipment, it's almost the same. It's close. The no reached 8.6, while the yes, it is only 8.4 million. And the unique subscriber and active subscriber, the active subscriber that will not churn, it is 39,293, and the yes is 27,283, while on unique subscriber, on no 44,079, on yes is 31,751. This is the churn versus occupation. We have already discussed that one. For data cleaning, we did the data correlation, and it has dropped two columns from 23 to only 21, and this is the new columns from dataset new data. And we store the new data into X, and we perform the test and train. We split the data, and we identify the best model. To summarize that, this is the summary of it. As you see, the decision tree has the highest accuracy score, which has 88.33. And we also get the precision and recall and F1 score. The score of precision is 94.94, recall 75.53, and the F1 score is 84.13. On confusion matrix, there are 8,624 customers that will not going to churn, and also predicted that will not churn. There are 243 customer observation that will not going to churn but predicted that will churn. There are 1,476 customer observation that will going to churn but predicted not to churn. There are 4,555 customer observation that will going to churn and also predicted that will churn. On building the model, we use the predictor variable and response variable. This is the coefficient determination. It is 56.18%. We also get the accuracy of mean absolute error, mean squared error, and mean squared root mean squared error. And for the mean absolute error, 0.23. For mean squared error, 0.11. For the root mean squared error is 0.32. And this is the decision tree plot model. So that's it.
Um, Hello, I'm Joshua Onyo from Group 2. So these are the libraries that are we that imported that are we going to use, and these are the churn data. So these are the columns, and we do a data cleaning. So for all the data attributes, so first remove the customer ID, then select all the columns that have null values. As you can see here, they have null values, and um, count all the null values on each attribute. So here, revenue have 141 null values, phones, models, and EQP days have one null values. And these four attributes are that have null values. We fill it with mean values. So now it shows here that all of the attributes don't have null values. Then let's move on the data types. So on the data types, it has this most of the attribute is int and some is float. So we change the float, convert the float to int. So now it has int, all attributes are int. Then this is the we store a new data. So this is the new data that are we going to use. Then next is data visualization. So this is the data visualization of the new data of churn and transform the churn into from numerical to categorical, yes or no. And this is the result. The next is this is now we can create now a data visualization on each attribute on new data. So we have here a churn and versus revenue, churn versus drop in unanswered voice calls, churn versus customer care, churn versus peak and off-peak voice calls, churn versus days of the current equipment or EQP days, churn versus unique and active subscriber, churn versus occupations, churn on retention teams. And now we clean again the new data. So we do a correlation. We have 23 columns. So as you can see on months and also on red accept, we have no correlation. So with this code, it will remove two of these columns. So it has now 21 columns. Then this is the new columns. Then we transform the churn from categorical to numerical. This is now the predictive variables and the response variables. So now we perform a test and train split. So in train, separate them into train, which is 70, and test for which is 30. Then we identify now the best model. So these are the models. So let's move on the accuracy score of each model. So we have here a score of each model. Decision tree, 88%. Logistic regression, 87. Support vector, machine, 87. Naive Bayes, 82. And last is KNN, 63. So the highest accuracy score is decision tree that we are going to use. Then let's move on the accuracy score, precision, and recall and F1 score. So accuracy score 88.46, precision 94.94, recall 75.53, F1 score 84.13. And these are the confusion matrix. So the true negative have 8,624. The false positive have 2,243. The false negative have 1,476. The true positive have 4,555. So now we model the decision tree. So we store again the new data. So predictor variables and response variable. Then we do a linear regression for X and Y train. So this is the intercept and slope. Then actual values and predicted values. So for actual values, this is the 20 actual values for Y test. Then Y pred, this is a 20 predicted values. And the coefficient of determination have 56%. And MAE 0.23, MSE 0.11, and RMSE 0.32. And this is the model of decision tree. And that's all.
Hello, my name is Patrick. So I will now demonstrate what we do on analyzing in churn analysis. So in the first one, we apply all the packages that we can use for analyzing and determine on what are the recommendation for the company based from the dataset. So here are our dataset. So there are 49,658 rows and 58 columns. And here are here are the attributes. And the total of attribute is 56. And I mean 57. And here are the non-null count and the data type. So it shows here to understand what inside the dataset or type what they apply on the dataset. So as you can see in here, shows the non-values and shows here these are the non the computer shows automatically or if there is a non-value. So let's proceed on the null. If there is something on the null on the date from the data set, so it shows here that there is a 141 null value on our revenue column. And phone, as you can see here, phone, models, and EQP days, there are one null value on their column. So let's proceed on this part. Um, in order to resolve the missing value, uh, we we don't clear or we don't delete any records, but we use to apply a mean value in order to proceed on the next process. So as you can see here, um, it already applied the missing value. So check again if there is a null value. And here this one shows the data type of each attributes, and most of them are integers and some of them are float. So in order to change the float into int, here this is the code that we use. And in order to display, just type to display df.d types. Then as you can see, all of the as as you can see, all of the attributes are now integers. Now we need to set into another new data that are the attributes that may be the cause of churn. So we are just simply analyzing on it, and here are the attributes that we use. So it shows in here in this code in this data set. So it shows 24 columns. So we usually get more than 20. And the data visualization. So it shows here the number of churn, and here are the answered of churn and answered churn. So there are 59.72%, and also well, the other one is 40.28%. So data transformation, let's proceed on that. Um, Transform churn data to yes and no. So because uh, it was a so as you can see, The 0 is means no, and the number 1 means yes. So as you can see in this part, there is no, then on the end it said yes. So let's proceed with the data visualization. So the number of answered of no and yes depending on the based on the revenue, if there is a chance of churn. So most of the people said no, and some some of them said yes. So answered no reached 1.6, while yes is reaching into 1.2. And here are the graphs that we use. The churn, unanswered voice call, and the custom care of peak voice calls, and the current equipment and active subscribers. We added more. Um, we just simply analyze the cause of why customers churn to their company. So we added more attributes in order to know that there is some uh, there are some things that can be the cause. So let's proceed with the data cleaning for new data. So in the new data, after we getting a new data, we just simply use the correlation. So here are the output. So getting the higher or lower is depends on the analyst if what is or what are they going to do after they see the percentage or the highest accuracy on each attributes. So in order to create a correlation matrix, here the code, and select the upper triangle correlation matrix. So in order to find the features with correlation less than 0.0, uh, in order to do that, after getting the features what is higher and lower, and this will be the time that you need to drop in order to get some of the relation attributes that can be used, or simply a get a record only to specify on what type of the cause of the churn. So here's the attributes of the new data, and converting into a, as you can see on the beginning, there is a no and yes. So after we analyzing it, we kind of change the the value. We turn uh, category categorical into a numerical. So this part we proceed to store in X and Y. Y data is the churn, while the others are on the X. So in order to do the test and train split, so here's the code that we use to get the train shape and the test shape. So here is the 70% of the train data. And let's proceed with the X test. Here the X test. Then it shows the X test records 30%. It shows the train describes. So next process is to identify the best model. So in order to do that, we analyze all of the best models that can be used for analyzing or used for identifying from the data set that can be used on it. So let's proceed with the logistic regression. We get the accuracy score of 88. We all get the accuracy of logistic, um, KNN, decision tree, the support vector, and then the naive. So as you can see here, the part in this part, uh, the highest that we can get is the decision tree. So we simply get the best model for this data set. So now let's make a prediction. So here's the test. So you can see in the end, here are the predictions, and we need to get the accuracy score of precision code F1 score from the data. Then it shows here the 88.46, like we use on the tree decision tree, precision 94, and vehicle 75. It's, it is good, not just go down below, it is becoming worse. So here is the computation matrix. Then there are 8,624 customers that will not going to churn, predicted that will not churn. So here are the interpret of the confusion matrix. So now we just imported the decision tree classifier. So we use now a decision tree. So here are the churn, the prediction, now the building the model, starring X and Y, viewing the predictive variables and response variable, and getting the intercept and slope. If it's fit from the other model, then the size of actual values and the predictive values is kind of the same. So there is no problem with that. Then let's proceed on coefficient of determination. So here are the result and the MAE, MSE, and RMSE. So here are the decision tree. So here are the result that not churn, the cause of churn and not churn. That's all. Thank you.